see how far we get into exponents here. Right. Just as a matter of have we not done this before?
Yeah, we did that one.
Okay, so I don't need to write down all this stuff. You already got the base and the powers and the exponents. As a quick little review, though, remember, let's say you've got 6 to the second power or 6 squared. That little guy there is the exponent. This little guy there is the base. And the exponent, the answer to that is not 12. It's not 6 times 2. It is how many bases get multiplied together. The exponent tells you how many bases get multiplied together. And so 6 to the second power is not 12, it is 6 times 6. There are 2 of these that get multiplied together. That's where the 2 comes from, and that is 36. And I think the book is just trying to review with you that if you have something to the second power, we also call that squared. Something to the third power, we also call that cubed. But everything else is called exponents. 6 to the fourth power is just 6 to the fourth power. And some examples of things they might give you would be this. 3 to the fourth power compared to 4 to the third power. 3 to the fourth power compared to 4 to the third power. Now on the outside you might go, well, those must be equal. Well, they're probably not. 3 to the fourth power is this. And 4 to the third power is this. What is 3 to the fourth power? 3 times 3 is 9.
84.
9 times 3 is 27. 27 times 3 is 81. It's not 12, that's 3 plus 3 plus 3. And 4 to the third power is not 12. It's 4 times 4 is 16. 16 times 4 is 64. So this one is bigger than that. Right there. I don't know if we need to go into that anymore. But one thing the book tries to get you to know is this, and it goes back to prime factorizing. Because if you have 10 to the third power, what is 10 to the third power? What's 10 to the second power? 100. Third power is 1,000. Fourth power is 10,000, 4 zeros. Fifth power is 100,000. And they want you to kind of get the connection to this because these are all tens. If you are prime factorizing 100, since 100 is 10 times 10, what always gives you 10 when you multiply it together, prime numbers? 2 and 2, 2 and 5 and 2 and 5, right? This is 2 and 5, this is 2 and 5. So you end up 100 is 2 2's times 2 5's. And the book wants you to kind of start recognizing the pattern here. If I have 1,000, it's going to be the same as 100, except you're going to add another times 10, which is another 2 and another 5. You know what I'm saying? 1,000 is 10 times 10 times 10. And all of those are 2 times 5's. So 1,000 is 3 2's times 3 5's. Guess what 10,000 is, prime factorized? 4 2's times 4 5's. Guess what a million is? How many zeros are in a million? No. How many zeros in a million?
6.
So how many 2's and how many 5's? 6 of each. Blah, 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 blah. They just want you to be able to recognize and see that pattern. See that pattern. Now, what do we also have to do now? Take out your notes also under decimals, I think. And changing decimals to fractions. this should be relatively short and relatively sweet. If the book asks you to change 3.75 to, let's see the exact word, a mixed number, how will that work? Well, you should know that the number in front is going to stay the whole number. What does 0.75 change to as a fraction? And again, best way probably to do that is read it to yourself. 0.75 is 75 what? 100ths. The only problem with 75 hundredths is you need to reduce it. 25 goes into both of them, so you end up with 3 and 3/4. Or if you, another one they might give you is this. What is this as 0.05 as a fraction is 5 over Lacey? What?
5 over
100. And again, that would reduce to 1 over 20. What would be 0.24 as a fraction? 24 100ths, which can be reduced by 12 doesn't go into 100. What?
2. 12.
Oh, cut them both in half. You can still cut them lower than that. What number goes into 12 and 50? 2, 6 over 25. 6 over